Swayam Prabha. Digital India. Educated India.
In the metal industry, where timing, precision, and safety are critical, even small innovations can lead to major improvements in efficiency. Today's program brings you a remarkable technological solution developed by SIH 2025 winners who are transforming the way hot metal and steel ladle are monitored and managed in steel plants. Let's meet the innovators behind this intelligent hot metal and steel ladle tracking system. Welcome to the studio, guys. Shivam and Ankan. Hi, how are you doing?
We are doing fine, sir.
Okay, great. So, to begin with, let's know something about you and your team.
We are all a team from NIT Raipur. We all belong from the Metallurgical and Materials Engineering branch. Four of us are from the sixth semester, and the other two are currently from the fourth semester student.
So, now let's talk about the project that you did at SIS 2025. So, what was the problem statement that you picked up and why did you pick it up?
So yes, the problem statement was of the steel ladle tracking, and it was to monitor the ladle within the industrial environment. And why we choose this topic is because that we have exposure to the steel ladle industry, and we know about how those processes are done within the industry, as we are from those department only. And in the second year industrial visit, we have also experience about how these ladles movements are there. So it gives us an extra edge or advantage, I would say, over other competitors, that we have an already knowledge about how those movements of the ladders are done, how those tracking is done currently, and all those things.
Okay, so just before we move on to the next part of this, let's try to understand this entire terminologies like steel ladles and all that stuff for a person who is not very well acquainted with the steel industry. So please explain to a layman what exactly are we talking about here? What are these steel ladles? I mean, why are they used? How do they work? And so on and so forth. Just clear the technicalities behind this.
So ladles are basically nothing but the containers that contain the molten steel, and it is used to transport those steels within the industry in different workshops. So let's assume that we have a different quantities. So let's say we have 30 liters, we have 500-liter capacities of those ladles. Depending upon those quantities, we have different sizes, and they are comparable to a bucket. Okay, just the material of the buckets are different. The outer shell is of steel, and then inner shell is of refractory material. So these helps to maintain the temperature of the molten steel, so that it remains at a liquid temperature even when even during the transport and after it reaches to the shop, so that the further processings can be done.
Okay,
So
so
it's just a container.
Okay. So till now, how are these being monitored before you pitched in with your innovation?
Yeah. So till now, this monitoring was done by painting numbers over the surface, and these numbers were then noted manually onto the shops, onto the exit base, and onto the entry base. So by manual notation, these numbers were maintained and the records were maintained, and then after manual notation, it was then manually input to the system, so that we can get a digital data for further analysis. So that's how the previous or current system, I would say, was doing the monitoring.
Okay. So now that we have a perspective, now let's understand how your innovation comes in and how did you improve upon it.
So as far as our innovation is concerned, so we have removed those number systems, and we have introduced a ring system over the surface of the container. So the rings would contain a specific color, and that color would be encoded to a specific number. So let's say, like I have encoded a red color to digit 1, a yellow color to digit 2, and say a green color to digit 3. So if I would want to give a ladle a number of 120, so how would I give it? So I would stick a red color ring around it, and below that I would stick a yellow color, and then below that I will stick a green coloring around it. So on the basis of reading those rings, I can identify what's the ladle number. So that's the basic idea, and then we will use cameras to identify the colors of those rings, and then it would digitally convert those colors to the numbers, and then we can know the ladle's position by detecting where the camera is. So we have say 10 cameras, and then we know the location where the camera is placed, and ladle is detected from that camera. So yeah, we have the ladle number and then the location of the camera, so we know where the ladle is located.
Okay, so in terms of efficiency and productivity, how much improvement do you think this can bring about?
So first of all, it vastly reduces the manual time that is required to note the and then note the numbers and then the errors that are related to it. And then it also reduces the time required in the service bay. Like we have to regularly paint the numbers as it deteriorate over the time. But that's not the case with the rings, as we have a specific material and all those things. So that protects us with the service time delays, and then improve the overall productivity of the plant, and also reduces the stress over managing the ladder's positions at the different times, and it also provides us with an effective analysis system from which we can analyze what's the further changes that we can do within our systems
Okay,
within the
what is
production.
this? What is this system of analysis? What analysis are we talking about here? Can you explain that also?
Yeah. Yes.
So, so basically, the analysis that we are using here is basically based on the machine learning model and the computer vision we are using. So the machine learning model is basically that we've used here is YOLO, that is generally used by analytics. So what it generally does, it creates what is a region of interest around the ladle, and based on that, matlab, under the region of interest, it will do all the analysis. It will analyze the colors, and it will convert it into the digit, and it will show on the screen.
So, were you able to put this into practice in the actual industry scenario? Were you able to, do that?
We are currently contacting to the industries, so we can actually simulate it within the real industries. And but now we have tried to create a small scale environment like a dusty environment to simulate if it's the detection is completely clear and it does not changes upon different environments.
Okay, so what was the reaction from the industry people when you told them about this innovation of yours, when you explained this to them? So, what was their reaction?
Yes, so one major reaction that we got was that our idea was quite unique, and it's not something that is currently available within the industry, or anything related to this is available within the industry. So it's a raw idea, um, quite innovative idea is the review that we have got from them.
Now, tell us about your SIH experience. Like, how was that, and how did that turn out to be for you personally and for your team, of course?
Overall, SIH was it was very unique. It was our first time experience for at a Smart India Hackathon. It was very unique, and actually it was everyone's first time going to the finals. We really didn't have much expectation. We just went there and thought to give our best. We didn't go with the view of winning or something. We just went there with the perspective to create a personal change, or to create a change or an impact in the industry.
Yeah, sure. I mean, that of course you are doing with this, very path-breaking kind of a system that you have developed there. Okay, so now talking about the judging rounds, the mentoring rounds, how did they go? The progression, was it smooth or was it very challenging for you?
Yes, the judging round was quite challenging on our part because the prototype that we were developing within the 5 days, and we have to develop a data set that is required to train our model. So those data sets were being trained manually, and because of those, we have a time issue, and then within the first two judging rounds, we couldn't complete those training models. So yeah, we couldn't. Completely show the prototype that we were trying to show at the final round. But yeah, around the final round, we have completed those everything. But yeah, but till the second round, we were still showing the procedure that we were proceeding with and what's the progress related to that. And additionally, after the judging, we were getting reviews, so yeah, that helped us a lot.
So, what kind of inputs did you get from the judges?
On the review side, I would say if we were quite not assuming it right, or but for the till the announcement of the results, we were not expecting a winning result for our team. Yeah, and after the reviews of the first round and the second round, we were quite disappointed as we what we were the review that we got was not what quite we were expecting from them. So yeah, might it be a mistake from our side in understanding the reviews or anything? But yeah, we kept on improving based on the reviews, and then yeah, we got to win the SIH.
Okay, great going then. So, tell me, where do you go from here? Where can you take this, and do you think you can put more of R&D into this and take it to the commercial level, take it to the industry for actual usage? I mean, where do you stand right now?
Yes, we are trying to get it to the industrial stage. We are currently trying to contact the industries so that we can try to simulate within the industrial environments. And as soon as we get an opportunity to simulate it within the real environment, then we would start developing according to the prototype to the industrial needs requirements. And then we can finally try to implement it on a whole industry level so that it can helpful for the complete development of the steel sector.
Okay, so have you already started working on a plan to take it to the startup level and monetize it, or you're yet to begin that?
Yeah, we are working. We
Just
are
began that. We are contacting few industries. We are also actually contacting our professors who are in contact in various steel industries. So we are also trying to optimize the means our model so we can to improve the accuracy and all such stuff. So yeah, we are on this process.
Okay, great. So, all the best for this effort of yours. I'm sure you will make a very big impact on the steel industry. And congratulations once again on winning the SIH 2025. And thank you so much for joining us today and sharing all this innovation of yours with us and enlightening us about your, work. Thank you so much.
Thank you, sir.
Thank you, sir.
That brings us to the end of this insightful conversation with the innovators behind the hot metal and steel ladle tracking system. Their solution shows how smart automation and real time data can transform complex industrial processes, making them more efficient, safer, and better coordinated. Stay tuned for more inspiring stories of innovation that are shaping the industries of tomorrow.